Task number 6. Now this is getting into spicier territory. We are going to make a new type of ant, a flying ant, or flying ant day. I don't know why there's a day. Flying ant has a 20% chance of, well, a queen has 20% chance of giving birth to a flying ant when the stage is advanced. Takes 3 stages to mature. Oh, it has food capacity. Interesting. Which we don't use. But let's kind of lay it out. And then once it matures, it moves to a random location. So that's what means flying. It's really teleporting to a random location in the grid and set up a new nest. This new location should not already contain a nest. We'll see that if the new location contains food, this is going to cause some trouble. But yeah, so this is a good chance to get familiar with how the code handles different things. So, where are ants born in the code, obviously, right? So that's in Nest that the queens is, no, sorry, I want to copy this and then paste it and rename it to Z6. Okay, we're here. Right, so let me just put that to the side real quick to see what we get here. So a new flying ant class with the required method to operate as described. This is kind of very, yeah, whatever, we've told you. And then update the Nest class. So this is where they're created. And then modify them to make them move. Not inform the user when it's born and when it has flown the nest, and when setting up a new nest, call the flying ant. So there's a whole bunch of concepts we're going to see. Actually, I've not used this yet. I found this super helpful. Wait, what? The outline view, super helpful to jump straight to certain classes. So we have cell ant, queen ant, worker ant. Yeah, between after worker ant, worker ant, a new class, if you will. I should put that back here. Class flying ant. In here it's ant. Yeah, I guess this is kind of what we're going to be doing. So they want like 5. 4 reasons that will become apparent. I also, is it amount of food carried? Amount of food carried, yeah, this guy. In similar, oh, no. I'm going to set amount of food carried to -1 because there's a whole bunch of stuff that's driven by, oh, is it larger than 0? What's wrong here? What's the problem? Oh yeah, okay, we kind of want some. No. What? Is that dumb indentation again? Right, this is good. That's my super. That's my init. Calls the super. Same parameters. Like where is it now and where is its nest? Type event is flying in lowercase. Food capacity that told us to put 5. I'm not gonna use that. I mean, just they probably whatever. The methods we need to override are, well, we'll leave it at that for now. And let's just kind of make them spawn in the nest. So in the nest, advanced stage is where for each of the ants, and we're sort of counting the ones that belong to this nest. And this is how much they eat. So each queen eats 10, each regular ant each 2. We then subtract this, and then if we don't have enough food, we kill some ants randomly. Where's the random? Yeah. By now, this is a little bit dangerous. No, that's cool. We're fine. Sorry. So what you don't want to be doing pop or remove. You do not want to change the content of a list whilst you are in a for loop iterating over that list, because this is all going to break the iteration. You might skip an element, or I don't know if you do them twice, but whatever, right? And then this is the spawning. So for each of the queens in, yeah, I mean, we've updated the number of queens. We keep track of the number of queens when we spawn them. So that says the number of queens in the nest. So for each of the queens in the nest, we draw a random number. And if we have a 50-50 chance of spawning something, and within that, we have a 2% chance of spawning a queen, right? That's here. So I'm going to use the same number. Now, they've told us, they didn't say when the queen spawn an ant, it has a 20% chance of, no, actually they do. No, when the stage is on, 20% chance of a queen giving birth to a flying ant. So I'm going to put it, my point is I'm going to put my conditional if on the same randomly drawn number right? Put my conditional here. So we might spawn a regular round or a worker end, but on top of this, we're gonna spawn a flying ant. So that's the 20% every return. And we're doing the same thing. So ants.append, we append a flying ant with parameters with the same parameters. So all of that stuff. Because of course ants are born in their nest and that's what they belong to. So we've done the new class, we've made them born. Now advanced stage to make them born, and this is a little bit fiddlier. Not gonna put that in simulation, by the way, the message. This modify the simulation class to put in the message. I'm just gonna say a fly ant is born. Right, and now the real complicated thing, in my view, is all the stuff in simulation where this is really the thing that makes the simulation tick is advanced stage in simulation, where for each of the stages we advance, there's some pheromone stuff, there's some ant stuff, right? So in the ant stuff, we want to advance the stage of the ant, or flying ant will pick up the advanced stage. This only increments the kind of age of the ant by 1. And then we use the current cell. Now, the problem here is that all of this is predicated, kind of expects that your ant we're looking at is a worker ant. In fact, because of the thing we've just created, this will find that there's queen ants are not going to be affected, but the only reason why the queen ants are not going to be affected is that the queens stay in the nest, and the nest contains food, but the cell of the nest does not have food, lying on the ground, as in food returned by get amount of food, which means we'll just kind of, break out anything. So this is where my get food carried is -1, so none of these are going to kind of go into those branches. So I have the ant, I have the current cell. If a.get, so in it's not an entity, it's not in cell, it's in ant, I have a get type event, yes. So if a.get type of ant and bracket is equal to flying, then what do we do? Now this is where I could, so the logic of aging the ant, I'm just going to say I'm going to need a method where it flies out. But I'm going to get back to this in a minute and on line 255 and find my flying ant in and put the new method so that I understand what I'm doing. Def fly out. This is going to take self. This is going to take number of rows because we fly to a random location. So we need to draw a random row and then a random column. And so for this, we need to know the size of the grid. Number of columns. If self stages, if that is larger, takes 3 days. I mean, is it larger or equal? Larger or equal, right? 3, 0, and 2, 3, whatever. So only if it's mature, we are going to... Now, I have a really good way of finding something that doesn't have a nest in it. And which is in... if I search for row equal to 2, yeah, okay, so this stuff, right? So we set the row, we set the column. The first nest is always in 2, 4. So we're just going to kind of draw a random one until we're not in the first nest, which maybe not without add food to sell. So here, this is just number of rows and number of columns that I've got from the parameters here. And then we're just setting, so the simulation makes the ant move in that it calls the get next cell to move to or whatever, but it's within the ants that the ants actually move in that we change the row and the column. which means that in the instance of a flying ant, do I have a row? Yeah, I want to set the row of the ant to my row variable that is not 2 and 4 because we're avoiding those, and column equal column. So this, if the flying ant is old enough to fly, it will fly it to another location that is not the starting nest, but it may contain a nest. Now, the flying ant doesn't have enough information to know where the nests are. It's only the simulation class that does. So if I go to my number line 255, we're going to call fly out, and then we're going to use a number of rows, right? We need to pass self number of columns. And we have the new cell to which the ant has flied is this exact expression, right? Because a get row, a get column now will return new values. But this cell still may contain a nest. Now, there's the question as to whether, if I land on a nest, do I wait for the next stick to move out? I'm gonna do that, although it might not be quite as helpful. So there is a is nest in so in simulation. Display menu, cell reference. No, and this is the main. We don't want the main. In the simulation, not in it. No, set up at nest at foot to get index get nest in cell. This is helpful. Yeah, get nest in cell. That's the one, right? So get nest in cell. You pass it a cell, and then it goes over all the nests. And if there is a nest in that cell, it returns the nest. Otherwise, it returns none. So if I go back to, was it 255, right? If self, well, actually, do we do cell for this one? Get nest in cell at new cell. If this is none, then we are going to set up a nest. There is a method for this as well. Create nest, set up nest at, look at that, right? It takes one column and will actually create the nest as well as the queen and all of the workers of the nest. So I'm back to my, well, it's 255. So self dot setup nest at. Now setup nest at takes row column, which is slightly annoying because we already had the cell object, but I can just pass this back here. Now we've done the, if that's the case, do you know what? I'm going to make two separate messages. So print that's left the nest. And in here, I'm going to print flying and set up a new nest at, and then put those coordinates here again because that's a helpful message, right? Now, done this, done the instantiation, so like where you've got a 20% chance of spawning a flying ant. We are informing it when it's born, although not in simulation. We are making it fly the nest to set up a new nest and informing then, but we need to curl the flying ant. And this is what I was telling you about, which I can't remove it from ants or self underscore ants because I'm iterating over ants. So I'm going to say ants to curl. That's the empty list. And what we're going to do here and add, I'm going to append here, append A, which is the current ant, which is a flying ant, to ants to curl. And I'm going to, you know what, I'm going to curl them like right here because, yeah. No, I can't because I'm iterating over on. So I need to be outside of that loop. Oh, yes. Okay, so we're looping over on's. Then after that, we're looping over nests. So because we're advancing the stage here, I'm going to want to call the flying ant on that line. For a in ons to call self underscore ons pop. No, we don't pop. Pop is by index. We remove a. Okay, well, I mean, I'm hopefully tentatively confident. They tell us simulation number 1 and do it like 50, no 5, right? Because 5 you may have a chance that, and then you might want to push it. Yeah. So 1, 5, 5. Okay, we've got a flying ant. So let's move them one by one. So it's left the nest, but presumably it's not set up a nest. Ooh. Ah, yes, no, that's the problem, right? The problem here is because there's a nest in a place where there was food, and the thing throwing this error is the queen, because queens are getting picked up by this, because the queen of my new nest is on a cell that has food and has no food carried and has that. So I can deal with that in two ways. One is, and is it new cell get amount of food? Yeah. So if I say you can land, if you land on a nest, it will just could fly again, right? Kind of. You only set up a nest if there isn't a nest in the cell, but currently we're setting up a nest in a cell that may have some food. So I'm just gonna add this, and that means that should defend against this error. 1, 5, 5 again. Okay, has born and has left the nest. Has it set up? Are we setting up? Maybe I don't know where it's left the nest. Let's have a look at what my grid is like. Okay, advanced one stage. So they're leaving the nest, but are they kind of? There we go. Right, we set up in a new nest. I don't know where. Well, I guess they're kind of going on the food. I don't know why they're flying so much. And also the problem as well is that it's misleading here because they say. So at the moment, if my flying ant is landing on a nest or landing on a cell with food, we just skip all of this, but we have printed that. So we skip all of this, and maybe in the next stake of advanced simulation, we will have, we will kind of make it move again, right? Because I'm always kind of calling fly out every time I encounter a flying ant, because otherwise it would have been killed. And I mean, surely that kind of works. I think that testing parameters are not enough. So what if instead I would say, what if I just do while not, as long as we don't have those conditions, as long as those conditions are not met, we are going to again do this kind of new cell thing. And which means that now I don't need to actually the flying out of the nest will mean that is also the same tick as we're setting up a new nest. So I just need to do this, right? So we're flying out to a new cell and then repeating that flying out. I also just need to kind of change it. And we keep on doing this until we land on something that's empty, basically. And then we set up a nest and send a message. Let's try this if it works a little bit neater. Submission number 1, 5, 5. So it's born. That's good. So if I advance the simulation by one stage, why is this not working? What's happening? Okay, simulation number 1, 5, 5. 1 flying on is born. 4. Is it looping forever? Is that what's happening? Okay, maybe I broke it. Maybe I shouldn't have try and kind of stretch it and overreach here. Is that the is my random location thing like broken? Let's see. I mean, if I put a breakpoint here and then try it again. No, I need to debug it now. Yeah, I've sort of gone on a side quest here. I feel like this was complete, 10 minutes ago, if we want to kind of figure out. Because really, okay, realistically, you will not encounter something like this on the paper 1, but this is a really good task because it forces you to figure out how the whole of that stuff works, right? You kind of find out where in the code are aunts spawned, where they're moved around, what kind of logic we have. Flying ant is born, excellent, and then it's trying to fly. And this seems to be okay. So I'm going to put a. Let's just. Yeah, not helpful. New cell, row column. So it seems to kind of always want to go to the same new cell, which is not great. Again, yeah, it's stuck. It's stuck on the nest. Now, what's the deal? I think the problem might be in fly out. Okay. Well, I mean, am I even getting into that random draw? Okay. So I actually need to put the age stuff in a different place, because like at the moment this is looping in here as if it's always in the same. Right, like my flying ant has not matured, but I'm still trying to make it fly out because the thing that checks the maturation is in the fly out method. But because the simulation code that advances the stage behaves as if it had flown out, so I just want to suppose I could do if new cell equal current cell. Continue. Actually, in fairness, so what I've done is because my amount of food carried is -1, I'm never going to get into those clauses. But if you want it to be slightly precious, you could put a continue so that we skip them as well. There's several ways of going about this. So if I just kill my hello, stop the debugger. No, this one. Right, now I should have submission number 1, 5, 5. Flying in is born. No, I'm still stuck in an infinite loop because I messed it up. Oh yeah, okay, so that's because I put it in the wrong place. That's fair. This is annoying, right? Because I did a version of this before, so I don't want to kind of go completely cold, and I didn't do exactly in the same way. Now the differences I've put in there, I've sort of tripped me up, and now this video is now about 10 minutes too long. But well, we make do. We're learning stuff. 5, 5. Okay, are we not gonna birth flying ants? Yeah, right. So it's born and it set up another nest in the new place. In fact, if you kind of continue with this, that's the nest here. If you keep going at it, you'll see that the stats means that we're very quickly spamming the map with there's going to be nests absolutely everywhere, and because we don't have food decay or we don't have ants dying of old age, it's going to be ants everywhere because each nest starts with like is a whole bunch of ants. So it's not really a balanced simulation, but at least we have this new type of ant. Right, let's go compare. Select the compare, Z6, compare with selected, and that's YDIF. Right. So from the, I don't know, like this is all the simulation code with the culling. Remember the culling, where you kind of put it aside, and then once you're outside the iteration, you curl. My new class, nothing fancy. They wanted the food capacity to 5. That really doesn't matter. This is important because that means it's not going to get treated as a worker aunt in the simulation. Then we have our main flyout thing that handles the maturation. Now we could have handled the maturation in simulation again, so like only call fly out once the aunt is mature, but I think it makes more sense for those parameters to be part of the aunt class. The spawn that happens in Nest, they told us a 20% chance, like separately, which means we might actually, if our no one is smaller than 20, is also going to smaller than 50. So we go every time we spawn a flying aunt, we're also spawning either a worker or a queen. But this is what they've asked us to do, so we're doing what they've asked us to do. And then in here, we have a special conditional within the main loop. So can I fold it? No, not in the diff. This advanced stage will, for each of the stages you want to advance, there's a loop on pheromones and pheromones to delete. Note this there, right? Kind of self pheromones, and then you add to delete, and then you remove them outside of the loop. So same deal. There's one looping on aunts, and this is really all worker on stuff, but we've added a new flying on stuff. And then after that, we do the curl. But also before we call the nest, because that means our dead curled flying aunt is not gonna consume any of the food for what it's worth. We want to be very precise. Now, this is where we get into interesting territory, because that's learning a lot about the code in tasks like this, but equally tasks like this get so many moving parts that they need specified very accurately and tested very, very accurately, which is not representative of an actual AQA question on the paper. But those kind of questions for practice are still really, really good practice, because you're learning about how to create a new aunt, an inherit thing, you're learning about spawning actually the aunt and instantiating the object in the right place, the way the information just cycled through the code. So an aunt doesn't know about the size of the grid, which is when I do fly out, I do need to pass out the number of rows and number of columns, which is something that the simulation knows. So those are good practice, and I hope now that we're kind of getting into the spicy side of the ZigZag task, I'm looking forward to even more of these.